to Physics 2, Lab 1, about charged tapes. So in this presentation, we're going to go through the experimental goals and key concepts, then procedures, results, and then the discussion. So let's get to it. So the goals for this experiment were to prepare two charged tapes, observe the interactions between the tapes and another object, that those two objects being a hand and a pen, and also the other tape, and then calculate the excess charge in one of the tapes, as well as simulate the interactions between the charged tapes via WebB and in a computational model. So the key concepts that were explored during this lab were, so first we used Newton's second law, which just was used in the calculation of the force of gravity, which the electric force is being used to counteract in our experimental setup. And then we also used the electric force, which is Coulomb's law, which is used to calculate the electric force and the magnitude of the charge on one of the tapes, or actually each of the tapes. But we made the assumption that the tapes had the same charge. We also used this force to determine the charge of the tape, the sign of the charge of the tape, because of whether or not it attracted or repelled a negatively charged pen. So this is the procedure for the lab. We created U-tapes by folding the tape, and then we used friction to generate a charge in both the tapes, and then created a bridge, and then saw the forces acting on the tape in the bridge. So when this lab was done, we observed that the two tapes had repulsive interactions. The U-tape had an attractive interaction with the pen and the hand. So the pen was negatively charged. We knew this because it was rubbed on clothes, and so the tape must have been positively charged because it was attracted to the hand. So when in the suspended bridge position, we observed a separation distance between the two tapes that was maintained at 1.9 centimeters, or 0.019 meters, which would be the magnitude of the R vector in our calculations that I showed earlier. So these are our free body diagrams. As you can see, our forces are labeled. I did the free body diagrams for both the forcing U-tape that was held by your hand, and the U-tape bridge, which was suspended in the air. So these are the results of our measurements, of our observations, as I discussed earlier. This was our separation distance, and this was the weight of the tape right here. So we used those to calculate the charge of both the tapes, assuming again that the tapes have a point charge and that the charges in the tapes are both the same. Here's a computational model, which was used to model the same thing. Here I just defined some constants as well as the gravitational force that was acting on the tape. And then here I also defined the electric force as being canceling out the weight, because we have the equilibrium condition that the net force on the tape was 0 because it was not moving. So and then here's just that same calculation I showed in the black earlier, but done in the WebB Python script, calculating the charge of the tape. And I don't know why it's called iteration, but this is the ratio deficient atoms to electrons. So we also used a model to determine the charges on all the electrons in the tape, and determine the electron deficiency level of that tape. So these are the results of that computational model. And as you can see, it's a similar force. However, the ratio deficient electrons was quite different. And this is because of volumetric analysis. Here's the ratio from before. It's right here. It's right here. So yeah, the volumetric analysis was used in the analytical model. However, in the numerical model, it was a surface area argument, and so that's the result of the difference, or that's what results in the difference. So as I said, that's why there's a difference in the charges of each individual electron. However, however, when we assume that the tapes are point charges, the readings are actually very similar. Those differences can be accounted for in our other assumptions, like the point charge assumption and the no wind resistance assumption. So these are the future questions that we addressed in this experiment. So the electrons are negatively charged. If the electrons charges were switched, the nothing would change. That's essentially like the answer to the first question. And for the second question, if if we used a line charge versus a point charge model, then the line charge would be more accurate because the tape looks more like a line than it does like a point, even though it's really like neither. So yeah.